The next topic that we're going to look at is chemical proportions and percentage composition. So in this video, I'm going to teach you all about the law of definite proportions and how to calculate the percentage composition of each element within a compound. So first off, the law of definite proportions. What is that? You may have heard of it before. Basically, it states that a compound always contains the same elements in definite proportions by mass. So that means, for example, anytime we write out a chemical formula, the proportion of the elements is always the same as what's written in the formula. Here's an easy example, H2O. So that's water. And we know that water always is made up of 2 hydrogen atoms and 1 oxygen atom. Okay, it always looks like this. Okay, and what ends up happening is we can actually use the molar mass from the periodic table to actually calculate some proportions there. So we know that, say, oxygen weighs a lot more than hydrogen. So overall, the proportion of oxygen is going to be much greater than the proportion of hydrogen within a water molecule. So here's some more examples. Carbon monoxide and carbon dioxide. So I know you guys have some blanks here, I think, to fill in. So I'll just talk you through the points. Carbon monoxide we know is produced by the combustion of fossil fuels when our supply of oxygen is low. And here's the dangerous part of it. It binds to hemoglobin in your blood in the same places where oxygen binds. Therefore, it reduces the number of oxygen molecules that can be transported around your body, and that effectively leads to organ failure. Carbon dioxide, on the other hand, is produced by the combustion of fossil fuels when there's lots of oxygen. It's also a product of cellular respiration. It is easily carried away from cells by the bloodstream. It helps to control the pH level in our blood, and it's used in a lot of other everyday applications. It's used in dry ice, in carbonated beverages, and in fire extinguishers. The reason why I bring these two substances up is because they are both molecular substances, but their formulas or their proportions are different. In carbon monoxide, we only have 1 carbon and 1 oxygen. In carbon dioxide, it's easy to see that we have 2 oxygens for every carbon. So that's to say that basically if we change the formula of a compound, we change the properties of it completely. It becomes a whole new compound. So this isn't really new to you, but it's just sort of another example of how the law of definite proportions works. So the definite proportion of a compound can be expressed in a few different ways. The first is, like I've already said, using the formula. So if we go back to my water example, we know that 1 molecule of water will contain 1 atom of oxygen and 2 atoms of hydrogen. And the formula is H2O, and that's always the ratio. You always have 2 hydrogens for every 1 oxygen. We can also look at the molar mass. So for example, water has a molar mass of 18.02 grams per mole. So when I add up my oxygens and hydrogens, I get 18.02. And it always contains 16 grams of oxygen and 2.02 grams of hydrogen. So even though I have more hydrogen atoms, my mass of oxygen is actually greater because the atom of oxygen weighs more. It has more protons and neutrons than a hydrogen atom does. The third one, which is new and which we're going to spend the rest of this video on, is percent composition. And that's the percentage of the total mass of the compound contributed by each element. So for example, the mass of water ends up actually being 88.79% oxygen and 11.21% hydrogen. So now what we're going to do is I'm going to show you how to calculate those percentages out. It's actually pretty simple. We use this formula here. Let me move that over here. So the percent of every element, or the percent composition, is the mass of that element in 1 mole of the molecule divided by the mass of the whole molecule times 100%. Okay, so it's the mass of the element in a mole divided by the mass of the whole molecule. So let's do 2 examples, and then we'll do a bunch more questions in class. So example number 1 from your notes. Calculate the percentage by mass of each element in ammonia, NH3, or nitrogen trihydride. So the first thing you have to do is find the molar mass of nitrogen trihydride or ammonia. So to do that, I know I've got 1 nitrogen and 3 hydrogens. So here's a little review. I'm going to do 1 times 14.01 grams per mole plus 3 times 1.01 grams per mole. So when I add it up, I can calculate my molar mass to be 17.04 grams per mole. So that's my molar mass of ammonia. So now to calculate the percentages, I need to find the percentages of each element within the molecule, okay? So that means I need to find the percent of nitrogen by mass and the percent of hydrogen by mass. So if I say have 100 grams of the substance, how much of that weight comes from the nitrogen atoms, how much of that weight comes from the hydrogen atoms. So like I said before on the last slide, and you guys have written down in your notes, the percent composition is the mass of the element divided by the total mass of the whole molecule. So for nitrogen, the mass of my nitrogen is here, 1 times 14.01, so that's 14.01 grams per mole, divided by 17.04 grams per mole, and then I times it by 100 to get my percent. So when I do that, my actual percent is 82.2%. There we go. Oh, I should have another significant digit. I think it's 82.23 maybe. And then my percent of hydrogen ends up being exactly the same thing. So I'll do this one in green, just to sort of show you. So my total mass of my hydrogen is over here. So it's 3 times 1.01. So it's 3.03 grams per mole, divided by 17, my total mass of the whole molecule. And again, times 100. So when I do that, my answer ends up being 17.87, I think, percent. Okay, now remember that your total should add up to 100, okay, because I know that my mass of my compound is only made up of nitrogen and hydrogen, so when I add up my two percentages here, I should equal 100%. Okay, which in this case I do. So let's do one more example. Calculate the percentage by mass of each element in barium periodate. So again, remember the first thing you do, the answers are there at the bottom. So the first thing you do is calculate the molar mass of barium periodate. So I have, in one molecule, I have 1 barium, I have 2 iodines, and I have 8 oxygens. Okay, so that means I have 1 times 30, oops, 1/3, I'll erase that. 1 times 137.33 grams per mole, plus 2 times iodine, which is 126.9, I think, yes, 90 grams per mole, plus my oxygen, which is 18 times 16, or sorry, 8 times 16 grams per mole. I'm running out of space. Okay, so you should all be able to do that really, really easily now and add it up and get 519.13 grams per mole. Okay, then what you need to do is, again, find the percentage of barium, find the percentage of iodine, and find the percentage of oxygen. So I'll color code those for you. So again, barium, the percentage of barium is going to be the total mass of your barium. So in this case, it's 137.33 grams per mole. Oh, I'm going to run out of space. Divided by 519.13 grams per mole. And then that's obviously times 100. So when I do that, I should get this answer here, which is 26.45%. Okay, so I'm going to let you guys set up the iodine and the oxygen on your own. And what I want you to do is check your final answers down here. So here's your iodine. Oops, sorry. I color coded that wrong. Here's iodine in blue, so it should be 48.89%. And here's oxygen, 24.66%. And remember, the percentages must add up to 100%. If they don't, it means you've done something wrong somewhere, and you need to go back and fix it. So the most common mistake is somewhere in your calculation for your molar mass, that 519.13. That is what ends up being sort of the biggest mistake that people make. So check that again, and then redo your calculations and make sure they add up to 100. And that's it for this video.